Our next section here is on arcs and chords. Arcs and chords. We've already talked about arcs, but chord is a new word. A chord connects 2 points on the circle. A chord connects 2 points on the circle. Chord connects 2 points on the circle. So here's our chord here, AB. Or of course we could say BA. So we got a lot of rules about chords, but basically we could summarize all the rules with if it looks equal, it is equal. If it looks equal, it is equal. So we have a lot of balance in these pictures. So here if we have a diameter and a chord that are perpendicular, so here's the diameter, here's the chord, they're perpendicular. We're going to get, the chord is going to cut the chord in half and it's going to cut the arc in half. Or in other words, if we just look at the picture, these two arcs are going to be equal. These two segments are going to be equal. And these two arcs are going to be equal. And it just kind of looks like that anyway. So I always just say if it looks equal, it is equal. So here EB is going to be 5 because it's going to match that 5, making D to be 10. Here PQ is 40, so QR is 40, making from P to R 40 plus 40 or 80. It's easier than it looks. Here, solving for x, these two are going to be equal. So 3x plus 16 equals 12x plus 7. Or if I move things over, 9x equals 9, x is 1. If it looks equal, it is equal. Same thing here, congruent chords, congruent arcs. This is saying, like, I'm just going to write, if it looks equal, it is equal. If it looks equal, it is equal. So these two arcs are the same if those two chords are the same. Similarly, these two chords are the same if those two arcs are the same. So here, let's see, arc HG here, arc HG, isn't that a central angle here? So isn't that going to be 90 degrees? Therefore, arc FG is also 90 degrees. So this gives me a right triangle, right? Oh, I see the 5, yeah. So then here, I was thinking I had to use Pythagorean theorem, but it's not even that. I just can set those two equal. X plus 2 equals 5. That's it. X is 3. If it looks equal, it is equal. Here the 60 degrees, because these two are equal, that's going to match 60 degrees, so X is 60 degrees. So these arcs are the same, central the same, 60, 60, 60. If it looks equal, it is equal. Everything's 60. So now we get another one of these circles that has kind of everything on it. But it doesn't all the questions aren't the same. Sometimes the answers are different. So here EF is 4, DF is 4, ED is 8. 4, 8. Not degrees, right, because that's a segment. If AB, and I'm going to erase every time because every question is a little different. If AB is 18, that's a diameter, then from A to C to the center would be 9. I'm going to erase that. If AE is 60 degrees, so now I'm talking about an arc. If AE is 60 degrees, then from A to D is also going to be 60 degrees, and from E to D is 60 plus 60 or 120. I'm going to erase again. The next one here, E to D is 130, so that's like this whole entire thing is 130. So then E to A is going to be 65, just 130 divided by 2. And then E to B is going to be 115, and I got that doing 180 minus 65, because it was semicircle. Okay, 2 more. Let's see, what do we have here? AD is 13. AD is 13. Remember, that's a right angle. FD is 5. What's A to F? What kind of shape do we see? It's Pythagorean theorem, right? And you might even now know this by heart. 5 squared plus x squared equals 13 squared. The answer is going to be 12, right? I'll write it out, though. So it's x squared is 144, and then square root of that is 12. Erase again. Last question. If AB is 20, AB is 20. So right away I'm going to know that, like, this guy's 10 and this guy's 10. F to C, that little baby guy there is 2. So, well, A to C I said is 10, and then wouldn't A to F just be 8? Because 8 plus 2 is 10. So all little questions, and on the homework you'll see you don't have to keep erasing. I just give you the different picture with every question. So the overall thing is if it looks equal, it is equal.